So in the last section we had a look at speech, how we understand it, how we generate it. Next, let's have a look at some of the experiments that have been performed to try to understand how speech is processed by our brains. Firstly, the type of errors that are made when speaking. Some types of errors are more common, others are rare or don't occur at all, and this reveals something about the underlying information processing in our brains. A relatively common error is using an incorrect sound within a word, often a sound used in a different word spoken just before or after the error. For example, someone might be trying to say cup of coffee, but the k sound in the word cup is carried over but rapidly corrected. So what is said is a cup of coffee. Sometimes sounds are exchanged between two nearby words, such as trying to say a crushing blow and having it come out as a blushing crow. These errors are sometimes called spoonerisms, after an individual who was reputed to make many humorous errors of this type. Only certain types of these sound errors actually occur. For example, a consonant can be replaced by a consonant, but is never replaced by a vowel. A sound error can result in a noun being replaced by a different noun, but not by a verb. And in fact, a sound error never inserts a sound that doesn't occur in the language, and it always results in either an actual word or a combination of phonemes that could be a word in the language being used. It's rare for two sounds to be exchanged within the same word. If a sound error is made, the relative stress placed on different words within the sentence isn't changed. You don't get replacements or exchanges with sounds more than about 7 syllables apart. And finally, there can be a longer than usual pause before a word, especially if the word is less familiar, which implies the need for a longer processing time. Another way to investigate speech is to track what we're looking at while we're hearing speech. For example, suppose a subject is looking at this scene and hears the words, "Put the pen on the pad in the pen holder." The instruction is to move the left pen into the holder. But if eye gaze is being monitored, when the sentence gets to the end of the word pad, eye gaze goes to the right-hand pen and the empty pad. In other words, the brain is initially generating a concept based on those first few words, which with the additional words is replaced by a different concept. And the final part of this discussion of speech is to think about the kind of speech deficits, they're called aphasias, that can result from brain damage. Broca's aphasia is an example of a speech production deficit. The patient typically can only generate 1 or 2 words at a time. So a mental intent to express pride in a son who's attending university might come out as son, university, smart, boy, good, studies, good. But although speech production is affected, comprehension of speech remains. Wernicke's aphasia, on the other hand, is an example of a deficit in speech comprehension. The patient's speech might consist of sentences like, "I told my cow with the radio but did not understand the fence." Grammatical, generated at an appropriate speed, but meaningless. The lack of ability to repeat sentences is often, but not always, observed in both Broca's and Wernicke's aphasias. In dysarthria, speech is slurred and/or has abnormal rhythm, but meaning is normal and comprehension of speech is normal. And in Tourette syndrome, one of the symptoms is swearing, excessive and uncontrollable.